Hi, this video is an introduction to writing chemical equations. We're just going to be looking at a chemical equation. You know, when we have a chemical reaction, when you're creating new substances, this video is going to talk about the chemical equation that represents that chemical change. All right, so first of all, this is really important. It's called the law of conservation of mass. And it is stated like this: mass cannot be created or destroyed in any chemical or physical change. And so I just kind of have this diagram down here. So we've got 2 hydrogens, 4 hydrogens here. And on this side of the arrow, we have 4 hydrogens. And over here, we had 2 oxygens. And over here, we have 2 oxygens. So if you look at this, the 2 sides of this reaction are identical in what they have and the numbers that they have, but they're just rearranged differently. So let's continue on. So a chemical equation is what represents the chemical reaction. So this is in model form. So here's the water. So we have 2 of those waters represented here as 2H2O. So this is our chemical equation down here. And then we're going to talk about what this means. It's yields. And then we get 2 hydrogens and oxygen. So again, this equation, matter is not created or destroyed. We have 2 oxygens here, 2 over here, and 4 hydrogens here, and 4 here. But it was a chemical change. We created something new that wasn't there before. We didn't have hydrogen gas before, and we didn't have oxygen gas before. Before, it was in those hydrogens and oxygens were in water molecules. All right, so chemical equations and the law of conservation of matter. I really like this balance because it keeps it's just a great visualization for me to remember that whatever we start with, it just kind of rearranges, and then what we end up with, we have the same number and the same kinds of atoms on both sides. They've just rearranged and made something new. Like here, we've made carbon dioxide, so we would have had some bubbling going on. Where over here, the carbon, see the black here, was tied up in the CH4 molecule known as methane. So chemical equations have got to be balanced so that they are showing the number of atoms of each element is the same on both sides of the equation. All right, so writing chemical equations. The left side of the arrow is called the reactants. This arrow separates the reactants from the products, and most people say the word yields when they do this. So yields, and then the right side is the product. So reactants yield the product. And reactants are used up in the chemical equation or in the chemical reaction. So we'd have some ammonia here, but it would get used up and the hydrochloric acid would get used up, and the products are what we form. So then we're making this product, ammonium chloride. So reactants are used up, products are made. All right, so let's learn about the symbols in these chemical equations. That plus sign, it's just like, plus in math. It's going to separate more than one reactant or product. The arrow, we say yields in chemistry, and that separates the reactants from the products. The S in parentheses means solid. It's identifying something, a reactant or a product that's in the solid state. The L in parentheses is liquid. It identifies a reactant or a product as in the liquid state. G identifies a reactant or a product in the gas state, and AQ stands for aqueous, which it's identifying something that has been dissolved in water. Okay, so let's go back to this really important law of conservation of mass. Again, restated, in a chemical reaction, matter is not created and is not destroyed. So you're always going to have the same number of and kinds of atoms on the reactant side as you have on the product side. Your atoms are going to be rearranging and forming new compounds, but the number and the kind of atoms remains the same. Okay, so here we go again. We've got this model equation. This is for the combustion of methane. And so we've got CH4, so here's our chemical equation. And we've got two O2 molecules yielding a carbon dioxide molecule and two water molecules. Let's see if the law of conservation of mass has been obeyed. We have one carbon, one black, one carbon over here. We have 1, 2, 3, 4 white hydrogens, and over here 4 white hydrogens, 4 red oxygens, and 4 here. Now we could look down here at this equation, and this number out front here is called a coefficient. It means we have the number 2 oxygen molecules, and so everything is balanced. And we're going to spend some time in another unit learning how to write a balanced equation. So there is a little bit of math involved in this, but it's not bad at all. Now, the number of atoms has to be the same on both sides of the equation, so the mass of the reactants must equal the mass of the products. Now, we haven't talked about units yet, but the unit for mass is grams, and that has the abbreviation a little g. So here, our little g could stand for grams. All right, so here we have mercury oxide. 2 molecules of mercury oxide, that's our reactant, and it's decomposing, it's yielding 2 mercuries and some oxygen gas. Well, if we started with 433.2 grams of the mercury oxide, we would make 401.2 grams of the mercury and 32 grams of oxygen. Both this side equals this side. The grams on our reactant side equals the grams on the product side. So how does a problem look for you? It would look like something like this. You have 46 grams of sodium. It's reacting with how many grams of chlorine to give you 116.9 grams of sodium chloride? What you would do, it's just like an algebra problem. You would do 46 plus x is equal to 116.9, and then solving for x, I believe that's going to give you 70.9 grams of chlorine. We're going to practice this in class, but the most important thing for you to remember now is learning what all those symbols mean in a chemical equation, knowing the terms reactants and products, and knowing that matter is conserved. Have a good day.